We all kind of think of science as this perfect, clear window, right? A tool that just shows us reality exactly as it is. But what if that's not the full story? What if science isn't a window at all, but more like a lens that actually shapes everything we see? Today, that's exactly what we're going to dig into.
So, is science simply uncovering the cold, hard, objective truth of the universe? Or is the very act of doing science, the method itself, actually influencing what we find? That is the fundamental question we're going to unpack together.
To get into this, we've got to look at two totally different ways of thinking. On one side, you've got the pragmatist view. It's pretty straightforward. Science just discovers the universe's pre-existing rulebook. Simple. But on the other side, there's a more Socratic, a more questioning view. What if the tool we're using, our scientific method, is actually coloring our perception of those rules?
Okay, so before we can even touch that big question, we need to get one thing straight. We have to draw a line between the furniture of the world, the actual stuff that exists, and the rules we create to describe how that stuff behaves. Seriously, understanding this one distinction is the key to everything else we're going to talk about. This table breaks it down perfectly. So over on the left, you've got the properties of nature. Think of these as the fundamental building blocks of reality. Things like mass or electric charge. They just exist. Whether we're here to see them or not, they're there. But then on the right, you have the laws of nature, like our law of universal gravitation. Now, here's the insight. These laws aren't physical things. They are our human-made descriptions, our codified patterns that explain how all those properties behave. And this, right here, is the absolute key. Our law of gravity exists because the property of mass exists. The law is just our description of what mass does. Mass isn't created by the law is created by us to explain mass. This hierarchy is so important. Our descriptions follow reality, reality doesn't follow our descriptions.
All right, so now that we have that distinction down, the furniture versus our rules, let's build on it. Let's imagine reality has, well, two different layers.
Think of it like this. Layer 1 is just objective reality. It's the universe doing its thing, totally independent of us. It's the raw, unfiltered stuff. And then there's layer 2, our subjective perspective. This is the world as we perceive it, through our senses, our minds, and, this is crucial, through our scientific instruments.
So that leads to the million-dollar question, right? When physicists are doing their experiments and writing their equations, which layer are they actually working in? Are they somehow tapping directly into that raw, objective layer 1, or are they really working from inside their own layer 2 perspective?
Well, your first instinct, and it's a good one, is to say layer 1, of course. The whole point of the scientific method, with all its controls and precise math, is to strip away our messy human biases, all that layer 2 stuff, and see the universe as it truly is, right? Well, let's challenge that idea.
And that's where we run into a fascinating problem, something you could call the observer's paradox. This is where the simple act of just doing an experiment suddenly gets incredibly complicated.
Here's the core of the Socratic challenge. Every single experiment, no matter how simple or complex, begins with a subjective choice. The scientist has to decide, okay, this is my experiment, my measuring apparatus, and that is the outside world, the surroundings. But that line isn't a feature of nature. It's a line we draw in our own minds. Now, to be fair, the pragmatic defense is pretty solid. We build shielded labs, we create vacuums, we do everything we possibly can to isolate our experiments from the rest of the universe. We try our best to make that imaginary line a physical reality, to reduce all that noise from the outside world until it basically doesn't matter.
But here's where that amazing analogy on the slide comes in. Is perfect isolation even possible? Or is it more like trying to study a single drop of ink while it's still floating in the ocean? Sure, you can draw a conceptual circle around it in your mind and say, I'm only studying this drop. But you can never ever truly sever it from the currents and the temperature of the entire ocean that surrounds it. That boundary is a useful fiction.
And look, this isn't just some abstract philosophical game. At the most fundamental level of reality, in quantum mechanics, the observer effect proves this is true. The universe just refuses to be a passive object for us to study. The very act of measuring a particle changes its state. The observer and the observed, you just can't pull them apart. That line we try to draw just completely dissolves.
So, if that's true, if the very foundation of science, just drawing that line between our experiment and the world, is a subjective choice, what does that even mean? It means we've got to completely reframe how we think about science. It's not passive observation, it's an active participation.
This quote just nails it. The scientist isn't some spectator looking in through a window. The scientist is a participant, standing inside reality and actively making a choice about what to measure and how to measure it. The scientific method isn't a window, it's an action. And when you start looking for it, you see this subjective participatory thing everywhere. First, our measurements are always filtered through the limits of our instruments. Second, our hypotheses aren't just cold deductions, they are creative leaps of imagination. Third, interpreting data requires subjective judgment to find the signal in the noise. And finally, even peer review is a social process based on the collective judgment of a community. All the evidence is pointing to one thing: science operates firmly within layer 2.
So where does that leave us? Does this somehow make science less? Does it diminish it? No way, not at all. In fact, it gives us a much richer, way more profound appreciation for what science really is.
The first big takeaway: we have to ditch this idea of science as a perfect mirror of reality. It's not giving us a flawless, one-to-one reflection of what's out there.
Instead, let's see it for what it truly is: an incredible act of disciplined creativity. It's our most rigorous and reliable method for making sense of the universe, and it beautifully combines human imagination with strict empirical testing.
And maybe its greatest trick, its ultimate success, isn't finding some final absolute truth. Maybe it's about building a shared, stable reality we can all agree on, a world that isn't purely objective but intersubjective. That means it's a reality we can all inhabit together, operate within, and use to build amazing things. Science gives us a common map of the world.
And that really brings us to this final thought. Science isn't a perfect window. It's a lens. And acknowledging that it is a lens, one that's shaped by our own participation, doesn't make it any less powerful. It just reminds us to be humble, to keep questioning, and to appreciate that it is, by far, the finest lens we have ever created.